Hi all of you, good afternoon. Hi Saurav, Ritul, Vatsala, Sunil, Anugya, Deepak. Hi all of you, good afternoon. Yes, back again. I was telling some of my friends while walking in, asked me what did I do in my break. So I think I had a very nice voice rest. Okay, so my throat problem is now done. Okay, Hemant. And I like doing three things. I either like traveling, or I like some bit of reading, and third thing I love is sleeping. Okay, if I'm not woken up, I can sleep for 3-4 days at a stretch. Okay, so that's my mode called as dead mode. Okay, so my dead mode is on, and the person who gives me company is my son. Okay, he can also remain 3-4 days doing nothing. Yeah, it was a nice break. I hope all of you are rejuvenated now. Okay, Diwali break हो गई आपकी? Yeah? Doing nothing? अच्छा, चलो ठीक है. There's also a nice way of rejuvenating. But just make sure this momentum doesn't carry forward, okay? I'm always scared of break beyond 2 days. उसके बाद में ना वो फिर है ना body आलस हो जाता है. You start getting lazy. Okay, your body starts revolting when you get back to work again. Okay, so make sure that you are back. Chalo, let's get on now. So last class we were discussing sea floor spreading process, right? We finished off the continental drift. Then we said Wegener was completely discredited. His driving mechanism was a big failure because of his flaws in the driving mechanism. His entire theory was rejected, and it took another 20-30 years for the idea to be revived again. And we made one statement. We said the problem was not with the idea called continental drift. Okay, continental drift as an idea is right. Continents do move. Continents do scrape the ocean floor. The Sial ocean floor is the Sima ocean floor is denser. वो part ठीक है. Okay, what was wrong is the other aspects जो आपके 5 mistakes हैं. One mistake was the Sial Sima idea is not right. Okay, Sial continents floating over Sima, वो एक mistake है. Second mistake, the continent will not scrape the ocean floor while it is floating on the ocean floor. The moment float आपने कह दिया वो गलत हो गया. Okay, over the ocean. That was second mistake. The third mistake was he talked about all continents are moving north and westwards. Like ऐसा नहीं है. Continents can move in any direction. They can move southwards, they can go eastwards, they can go westwards. Okay, so the definite north and westward motion of the continent was the problem. The fourth problem was he talked about the driving forces which are erroneous. The driving forces because of sun and the moon, the driving forces because of Earth's rotation. He had borrowed the idea from Taylor without confirming वो right है कि wrong है. वो mistake था. And fifth one, mistake नहीं बोलेंगे, but एक limitation तो है. He does not tell us about the origin of the Pangea. Pangea as a supercontinent is the right idea. Pangea was there. But what happened before Pangea? How was Pangea created? Okay, how the Pangea formation was linked to the ocean and the crustal differentiation. So those ideas he had no answer to. right? So देखो ये एक टेक्निक है, always try listing any ideas you have or points you have in terms of bullets, 1, 2, 3, 4, 5 bullets. When I ask you what are the criticisms against Wegener, ekdam clear, 5 bullets I must have in mind. The problem of Sialsima, continents floating and scraping, the problems linked to how the Pangea was formed, the problem of driving. ये आपकी listing you should recall immediately. Okay. So anyways, that's discussing the problem of the Wegener theory. But I repeat, Wegener's idea of continental drift is not wrong. And all the evidences he had given, all the evidences were right. Because the evidences were not the evidences of the drift theory. The evidences were the evidences of continents drifting. ये दो अलग चीज है. Okay. Did the continents break and drift? Yes. That's how the west coast of Africa matches with the east coast of South America. Plus, you have seen even North American coast has some match with the African coast. Okay. So the shape fit is right. The structure fit is also right. Rocks are matching. Rocks of Africa, rocks of Brazil, rocks of Patagonia, rocks in Northwest Africa, rocks of US, they do match. So we have the shape fit and we have the structure match also. The third evidence was the fossil evidences, that the same type of life form found in different continents spread across oceans. जब life forms evolve होते हैं, the life forms don't evolve randomly at all places. There are some places where they start off. Okay. In case of Homo sapiens, our species, our evolution in all probability began from Africa, in parts around the area called as the Lake Victoria region. वहां से शायद शुरू हुआ था. Okay. And then the populations have spread. So वैसे ही the evolution of the reptiles, the trees, the flowering plants, and to find the same species or same type of life forms in South America, in Africa, in India, in parts of Australia, in parts of Antarctica, okay, it's too much of a coincidence कि same life form इतने जगह हो रहा है and across continents, across oceans rather. Okay, he said it's simple, bring all the landforms together. The Cyanonathus evolution was in South Africa, South America and Northern Africa. Mesosaurus was in South America and southern part of South Africa. Glossopteris across Africa, India, Australia, Antarctica. ऐसे कुछ discussions we had. Okay, how the fossils today are distributed. And the fourth evidence was the evidence linked to the climates. Okay, there is a climatic anomaly today. That the tropical areas with so much of forests, warm conditions, wet conditions, the tropical areas, however, they do not have the best coal fields. Whereas, if you look at the coal fields are more in the northern temperate regions. North America में है, Germany में है, Pennines in UK है, we have coal fields in Ukraine, we have coal fields in Siberia. So, how is it possible that the northern temperate regions, which today do not have dense forest, which today do not have the conditions for dense vegetation, वहां कैसे coal fields हैं? And how come tropical areas which have the warm conditions, wet conditions for forest, they don't have coal fields? The reason we said was, okay, you put the continents together and move them towards south. What is in the northern temperate regions now comes in the tropical areas. What is in today's tropical areas goes further polwards. And that is how lot of tropical areas also have evidences of glaciation. Guys, I am speaking out at one flow. I hope आप सब recall कर पा रहे हो. Okay, in recall sessions, your summary should have been done. Okay, और आप मेरे साथ mental jog करो, jogging your memory. ठीक है? So the paleoclimate evidences has two parts. One is the evidences related to the coal fields of northern temperate regions and the evidences of glaciation in the tropical areas. Okay, so India में भी कुछ glaciation के evidences हैं. evidences in parts of South Africa hai. That's because these locations were further towards the subpolar regions near Antarctica. That's how the glaciation deposits have now accumulated. Okay? So the four evidences of Wegener are right. Okay, but his driving mechanism was so flawed that he ultimately had to be rejected, and his theory was discredited. But then some developments happened during 1930s, 40s and 50s. Okay, two big theories that became the foundational theories of plate tectonics. One was the idea called convection cells. The mantle is not a quite solid body. The mantle is not a static solid body. The mantle in parts is molten. This is always a confusion. Mantle is solid. Mantle is dense rocks. But some parts of mantle, because of high heat, can melt. And those parts can circulate like air circulation, like water circulation. We call that as convection circulations or convection cells. और ये बहुत powerful idea था, because these convection cells are the main driving force why the continents are moving. The continents' motions are not because of the tidal gravitational pull of sun and moon. They're not because the sun and moon are exerting their force of attraction. Okay, the forces that move the continents are not outside the earth, they're inside the earth. And convection cells of Arthur Holmes became an important concept there. And I added one point here. While we know convection cells exist, the problem is even now we do not know why the convection cells develop where they do. Okay, the pura mantle is hot. Okay? The mantle is hot. Some part of mantle is molten. But wahi kyun melt ho raha hai? Why not somewhere else? So Nafi said it could be that that area has radioactivity, yes, but then that's too naive, too simplistic. जैसे कि सर यहीं क्यों बारिश हो रहा है? Because वहां पर clouds हैं. Not wrong, but that's too simplistic, right? Okay, यहाँ clouds क्यों हैं? वहां clouds क्यों नहीं हैं? कुछ जगह में clouds हैं yet no rain. So we want something more concrete in explaining why the convection cells happen. That is an unanswered question even now in modern geophysics. Although we know the mantle can melt and the mantle can circulate. That was, in brief, the convection cell hypothesis of Arthur Holmes. The next important theory was the sea floor spreading hypothesis. Again, a very powerful idea. The oceans are not static. The oceans do move. The oceans do stretch. The oceans grow in size. Oceans are created and oceans also get destroyed. This idea of Harry Hess. Harry Hess, he was a professor in the Princeton University. He gave some ideas. He said, it is linked to convection cells. So wherever the convection cells are rising, the lava, the magma is rising. That rising magma can break the oceans. And when the convection cells are moving apart, the ocean floor also gets pulled apart. But remember, the gap है, वो gap ऐसे खुल के बड़ा नहीं हो रहा है. Gap opens up, lava enters, becomes solid. Again opens up, again lava enters, becomes solid. It's a continuous mechanism of eruption and basalt becoming solid again. Again eruption, again solid. That's how the ocean is opening up, spreading, and new ocean is being created at the location of this rising cell. तो आपको 5-6 कंसेप्ट बताया था. One is, what is Moore बताया आपको. What is the Moore's axial rift valley बताया. The Moore is a continuous mountain ridge, and the Moore is broken. Because it's broken, there's a continuous rift fault, rift valley. Then we talked about how the age of the ocean increases away from the Moore. The oldest oceans are far away, the youngest oceans are near the Moore. So Moore is the location where the crust is being created. The ocean floor is being created. Away from Moore, wherever there is subduction limb, where the convection cell is going down, there the ocean also gets pulled down. It gets pulled down, we call that as subduction. तो जहां subduction हो रहा है वहां गैप छूट जाता है, called as the trench. And there's lot of crushing going on there, lot of scraping going on there. Sediments are accumulating there. We call that as the accretionary prism, right? You know what is more? You know the Moore Rift Valley. You know the aging the increasing age of the ocean floor towards the margins of the ocean, subduction and a trench formation, and there is accretionary prism. And then we said the spreading process of the ocean floor is not uniform, is not same everywhere. Some parts are pulled more and some parts are pulled less. If some part gets pulled more, that part of the Moore will get a bit more displaced. In some other location, some other part gets pulled more. Again, the Moore will get displaced. So the convection cells, ये जो rising cells हैं, okay, this is the ocean floor, the rising cell here, the rising cell here. This limb A and limb B, these two are not exactly symmetrical. In some places, this can be, in some places, I said, this can be more powerful. This can be more powerful. The ocean will get pulled on this side a bit more. In some places, this is more powerful. This can be pulled like this a bit more. So the Moore that we talked about, the Moore is not a continuous ridge like this. The Moore is broken into pieces. ऐसे है, ये displace होके यहाँ आ गया है, ये वाला शायद यहाँ आ गया displace होकर. Okay, the Moore is getting broken, and there are cracks here. We have called these cracks as transverse faults, also called as transform faults. I'll show one diagram to all of you. I hope I have shared that. Get uploaded. Just give me a second. Yeah. So if you all can see this one, is this a bit clear? No. पता चल रहा है ये वाला? Okay, so this is the Moore. This is the Moore here, and ये जो dark lines हैं, this is the crack. This is the crack. This is the crack, and this is the Moore. So Moore is not continuous. There's slices of the Moore across. Okay, we call those as transform faults. जैसे हर Moore पे है. The Moore is blurred. Okay, I need to give you a better diagram maybe. ठीक है, I'll do that. I'll do that. Yeah. So the Moore is not continuous. It has been cut into small segments, and the formation of the transverse faults. So if asked about this, ये question पूछा हुआ question है. What are the evidences of sea floor spreading? Evidences of sea floor spreading: the presence of Moore, the presence of basalt eruptions at the Moore, the presence of the axial rift valley along the Moore. We have the increasing age of the ocean floor away from the Moore. The presence of trenches, the presence of accretionary prism at locations of subduction, and we also have the transverse or the transform faults across the Moore. These are the evidences of the sea floor spreading process. Well, yes, the transform faults are part of Moore. Moore is a ridge. Moore is a continuous ridge system. इसमें क्या क्या है? इसमें यहाँ एक rift valley है, Mars पे you also have volcanic eruptions here. Plus, I said the Mars are cut, spliced like this. They कटे हुए. Yes, the accretion prism is where the oceans are getting crushed. The ocean features are getting crushed, scraped. Okay. वैली दिख नहीं रहा, अभिरूप थोड़ा और ध्यान से देखना पड़ेगा. ओके, आपको मैं कभी लेके चलूंगा. ओके, कोर्स खत्म होने तो आपको लेके चल के दिखा देंगे कहां कहां पर वैली है. ओके, सो विल शो यू सम मोर डायग्राम्स देयर. ठीक है, एनीबॉडी एल्स? जैसे ना दिल टूट जाता है तो सर दिखता तो नहीं है दिल टूटा हुआ. ओके, तो उसके सिम्टम्स होते हैं. ठीक है, समथिंग दैट काइंड. ओके, ओशन का दिल टूट रहा है, दिखता नहीं है पर अंदर रो रहा है. ठीक है, कैन आई मूव ऑन ऑल ऑफ यू? ओके, या ऑनलाइन स्टूडेंट्स ऑल गुड? ओके, चलो, you need to have a more clear resolution. Maybe next time I'll show that to you. Okay, same thing, Rustam. Transform faults and transverse faults are same. They also called as shear faults also. They also called as slip faults. Same thing. Transform faults and transverse faults. अच्छा, आप एक और point add कर लो. Okay, I will not discuss now. I'll discuss later on. Okay, evidences of more. Where I left you last class में, just add one more point there. Okay, there are bands of opposite polarity rocks. There are bands of opposite polarity rocks. Opposite polarity rocks on either side of the north-south, on either side of north-south Atlantic Moor. North-south Atlantic Moor. There are opposite polarity rocks on either side of, okay, the north-south Atlantic Moor. वहीं ऐड करो. Okay, they are related to the ocean floor. They are related to the ocean floor preserving. They are related to ocean floor preserving events of geomagnetic reversal. They are related to the ocean floor preserving events of geomagnetic reversal during the active volcanism events at the Moor. During the active volcanism events at the Moor. मैं कुछ लिखा दिया, टेक्निकल से लिखा दिया. I'll explain later on. वहीं पर ब्रैकेट में लिख दो या मार्जिन में लिख दो आप. Refer to geomagnetism for details. Refer to geomagnetism for details. Okay. So what's observed is, say if this is the ocean floor and this is the Moor system here. This is the ocean floor with its Moor system. What we found was, on either side of Moor, ये पूरे ocean floor में, there are bands of magnetic polarity rocks with reverse polarity. ये एक band of rock है. Okay. At the Moor, अगर ये साउथ पोल दिखाता है, ये नॉर्थ पोल दिखा रहा है, साइड में है ये है नॉर्थ पोल और ये है साउथ पोल. तो साइड में है ये साउथ पोल, ये नॉर्थ पोल, अगेन नॉर्थ पोल, South Pole. Okay, again we have South Pole, North Pole. So these are bands of reversed polarity rocks. इधर भी वैसा ही है. On this side also, we have the same. The bands of, ये साउथ है तो ये नॉर्थ होगा, यहां पर फिर साउथ है, यहां पर नॉर्थ है, फिर साउथ है, नॉर्थ है. So all reversed polarity rocks. These are reversed polarity rocks. Okay, we found something on that Atlantic Ocean floor. On either side of the Moor, there are bands of reversed polarity rocks, and these coincide with some event where Earth's field can also reverse. We call that as geomagnetic reversal events. हम पढ़ाएंगे बाद में आपको. Okay. So if they ask you question on what are the evidences of sea floor spreading, ये सारे points आएंगे आपके. Priyanka, other moors also have, but this type of perfectly north-south is best in the Atlantic Moor. We also have in Carlsberg Ridge, you are right. We also have in Indian Ocean, we also have in Pacific Ocean. But this was discovered first in the, or confirmed in parts of the Atlantic Ocean. And Carlsberg Ridge, you are right. Carlsberg Ridge एक ridge है Indian Ocean में, वहां पर भी है. Okay, but in the Atlantic Moor, this is very well preserved. Take all of it done here. So I'm done with seafloor spreading. Any clarifications you want? Anybody? Any doubts on this? I'm presuming आपने synopsis कर लिया होगा. Okay, or maybe you'll do it eventually. But any doubts? All good here? Fine. Then take a fresh page. I'm starting with now plate tectonics. Plate tectonics theory, the most important theory of geomorphology. Okay, and jitna bhi, up till now, whatever I have covered is part of GS. In GS, it's done very, very fast. Okay, in optional, we'll do a bit more details, but all of these are GS topics. The plate tectonics, and I'm sure you all have heard about this. Okay? So, plate tectonics, write down one sentence here. It is considered as a comprehensive theory. It is considered as a comprehensive theory that explains all the geophysical events. That explains all the geophysical events on the Earth's surface. It explains all the geophysical events on the Earth's surface associated with moving continents, fold mountain building, volcanism, earthquakes, and creation and destruction of the Earth's crust and its lithosphere. Creation and destruction of Earth's crust and its lithosphere. Okay? It's a comprehensive theory. It's like whatever we could have known, we have dumped in this. But remember, the theory is still not complete. आज के डेट में the theory explains many things, but there are still a lot of things we do not know. For example, I talked about the mantle currents. वो क्यों होता हमें अभी भी नहीं पता. Okay, and what was the type of the initial crust? Though we have some idea, again some speculations are there. So by and large, this is the most comprehensive theory that we know of. Okay, within bracket mention, it is not a single theory. But It includes many concepts. It includes many concepts into a single framework. It includes many concepts into one single framework. जैसे अभी आप देखो, a different person gave the idea called drift of continents. A different person gave the idea called as convection currents. Somebody else gave the idea of sea floor spreading. Somebody else talks about the concept of plates. Somebody else talks about how the earthquakes happen. ठीक है? तो ये सब जुड़कर एक थ्योरी बन गया है. But in reality, this is not one theory alone. Like, you know, it's like a creation of a mega theory. A mega theory में lot of other theories are there. They have done the research, they have found evidences, and ultimately fits into the bigger framework. The tectonics theory is actually like a large framework that explains much of what we know about the geophysics. And remember, it is an evolving theory. अभी भी इसमें refinement हो रहा है. People are discovering new things here, and they keep on adding to what we know about the Earth's surface. ठीक है? Okay. Now, what are its main contributors? Who are the main contributors? Just know some names. The earliest who talked about the continental drift. Okay. The earliest ones who talked about drift, ये भी contributors हैं. We have Wegener, we have a Taylor, okay, और एक French scholar हैं, Alexander Dutoit. Alexander Dutoit. I am taking liberties with the pronunciation and not how they pronounce it. So I am reading it like the way they write. Okay. So these three were the earliest contributors to the idea of continents are moving. They talked about continental drift. Okay. And the more modern ones, the more modern contributors, you know about Arthur Holmes. Arthur Holmes. Okay. He talked about convection current. You know about Harry Hess. Harry Hess. He talked about sea floor spreading. There is a scholar called as Lee Pichon, a French scholar again. He talked about the lithosphere. Floating over the asthenosphere. Okay. Then we have Mackenzie and Parker. Mackenzie and Parker. They gave a theory called as paving stone hypothesis. Add the names, please. Arthur Holmes, he gave the concept of convection currents. Harry Hess, he talked about sea floor spreading. Lee Pichon, Pichon. He talked about lithosphere floating over the asthenosphere. Okay. Then we have Mackenzie, Mckenzie, Mackenzie and Parker. They gave an idea called as paving, Paving. Okay, paving stone hypothesis. Okay, this was the earliest form of tectonics theory. This was the earliest form of tectonics theory. Mackenzie Parker. Then we have this man called as T. Wilson. He coined the word plates. जो plate use करते हैं tectonic plates. The word plate was coined by this man T. Joe Wilson. Coined the word plates. So 4-5 names you should know. Okay, who are the contributors to the tectonics theory? ठीक है all of you? Okay. Now, what are the postulates? इस theory का क्या ideas है? What are the postulates of the theory? Number one, okay, that Earth's outer layer is lithosphere. I believe you understand this idea now. Lithosphere क्या है? It is the first 100 kilometers of the Earth's surface. It includes oceans and the continent's crust. This is a cold and a hard layer. It is brittle. Lithosphere क्या है? The first 100 kilometers of the Earth's surface, it includes ocean crust, it includes the continental crust. Yes, Wilson, T. Wilson, Rohit, to Wilson, T. Wilson. The oceans and continents, this layer is cold compared to what we have inside. It's cold, it is hard, okay, and it is brittle. Brittle का मतलब क्या होता है? It can break. Think of a glass sheet. Okay, it's hard. अगर deform करके टूट जाएगा. It's a brittle. Okay. The lithosphere is broken into segments. Segments called plates. The lithosphere is not a continuous layer. It is broken into segments called as plates. तो ये अगर अर्थ का outer surface है, it's broken. A piece here, a piece here, a piece here, a piece here, ऐसे टूट गया है. Each of these are plates. Each of this can be part continent, okay, and part ocean. It can be majorly ocean. It can be, okay, a large block of continent. Okay, so it varies from place to place, called as plates. And these plates can be part ocean and part continents. They can be, okay, only ocean crust, or they can be majorly continental crust. Okay, the plates can be part oceans, they can be part continents, they can be, okay, only oceans. There's a Pacific plate is almost entirely oceanic. The Pacific plate है पूरा oceanic है. वैसे एक और plate है called as Nazca plate, NAZCA. ये भी entirely oceanic है. ऐसे बहुत सारे ocean plates हैं. Most of them are part oceans, part continents. Let's say African plate, the Indian plate, or the South and North American plate. They're part oceans and part continents, mostly. And some of them can be majorly continents. Jैसे Eurasia जो है, the Eurasian plate is majorly continents. We can have Burma plate. Okay. We can have Arabian plate. We can have a Burma plate. These are major blocks of continents. Eurasian plate, Arabian plate, Burma plate, among others. So the lithosphere is broken into pieces called as the plates. लिखा आपने all of you? Pacific plate, Nazca plate, NAZCA. Nazca plate, they are almost entirely oceanic. हम आपको दिखा देंगे सारा. Majorly continents, Eurasia. Eurasia is not only continents, but a good part of Eurasia is continent. Arabian plate is majorly continent. Burma plate again is majorly continents. ठीक है? But most plates are part oceans and part continents. Okay, so the pieces called plates. The third point is the plates float over the asthenosphere. The plates float over the asthenosphere. इसमें कोई दिक्कत नहीं है. Asthenosphere याद है आपको? Asthenosphere is what? Asthenosphere is the lower part of the upper mantle. It is still the depth of 300-350 kilometers. It is majorly olivine minerals. It is soft. It is semi-molten, capable of deformations. Take all of you. A few lines on asthenosphere. Asthenosphere is the lower part of upper mantle. Asthenosphere is up to a depth of 300-350 kilometers from the Earth's surface. It is majorly olivine. I'm going to write fast. I presume that you all recall what I have taught earlier. They are majorly olivine mineral and the layer is soft, semi-molten. It is capable of getting deformed under stress. To apply force, it is capable of getting deformed under the stress. Okay. And the fourth point is, as the plates float on the asthenosphere, as the plates floats on asthenosphere, the plates interact and are responsible for all geophysical processes. As the plates float over the asthenosphere, the plates interact. They interact with each other, and the interaction is responsible for all the geophysical processes that include mountain building, volcanoes, earthquakes, crustal formation, crustal destruction. Okay, so all because of the plates interacting with one another. Okay, mountain building, volcanoes, earthquakes, crustal formation, and also crustal destruction. The crust gets destroyed. Remember this idea जो पहले बार challenge हुआ था? There was an idea called as permanency of oceans and continents. Oceans once formed are forever. Continents once formed are forever. ये सब challenge हो रहा है. You know, continents can be created, oceans can be created, oceans can be destroyed. Something happens there. Okay. So put a star mark and write down. A tectonics theory okay, was a complete challenge. It was a complete challenge to the older idea of, it was a complete challenge to the older idea of permanency of oceans and continents. Older idea of permanency of oceans and continents. That's one point. Or a point. Okay. Tectonics theory dismissed the idea of continents floating over the oceans. It completely dismissed the idea of continents floating over the oceans. Actually, it is oceans and continents together. Actually, it is oceans and continents together as a part of lithosphere. Floating over the asthenosphere. ocean and continents together as a part of lithosphere floating over the asthenosphere. Okay? These ideas were part of the tectonics theory. और एक third point add करूं. Okay. Also it asserts that the forces that move the continents, are within the earth, Put a hyphen. Convection currents are within the earth, the convection currents, and not the tidal pull of sun and moon, and not the tidal pull of the sun and the moon. Okay? So what is tectonics theory? What are its postulates? And why we say this is the modern theory? Because it rejects some old ideas which are incorrect. We have new concepts that tell us about how the dynamism happens. Okay. So what are the plates? So we say some of them are major plates. They are very, very large. Some of the plates are major plates. Major plates may we have 5 of them mainly. We have the Pacific plate, the very large, the largest plate, Pacific plate. We have the Eurasian plate. We have the Antarctic plate. We have the North and South American plate. We have African. We can also add the 6th one, the Indo-Austral plate. These are the bigger ones, the 6 ones, the bigger ones. The Pacific plate, the Eurasian plate, the Antarctic plate, North and South American plate, African and the Indo-Austral plate. These major plates. And then there are certain minor plates. It's so smaller in size. Minor plates, Nazca, minor plates, Caribbean plate, Arabian plate, Philippines plate, Burma plate, Scotia plate. Okay, we have one called as a Somali plate. Know some names: Nazca, Nazca, Nazca plate, Caribbean plate, Arabian plate, Philippines plate, Burma, Scotia, SCOTI, Scotia plate, Somali plate. These are the minor plates, and there are certain micro plates also. They are very, very small micro plates. ऐसे बहुत सारे हैं. You remember? Okay, one is called as Juan de Fuca plate. Juan de Fuca plate. You can remember Cocos plate. हालांकि some of them classify Cocos plate also as a minor plate. Cocos plate, COCO, Cocos plate. We have a very old one called as Ur. It's a very old, okay, microplate. Ur is now part of Indian plate. Okay, ये अब जुड़ गया इसके साथ में. Know some 4-5 names. That's all. Juan de Fuca, JUANDEFUCA. Juan de Fuca plate, Cocos plate, and Ur. Ur is a very old microplate. It is now fused with the Indo-Austral plate. It's fused with Indo-Austral plate. Priyanka, it's a subjective idea. Large is large, but no dimensions mentioned. So it's all about how you see it. So nothing big deal here. Okay. So एक बार आप diagram देख लें. Show you some. You all can see this, right? So that's African plate. Okay. So this is the African plate here. Part continent, part ocean. This is the Indo-Austral plate. इसके भी दो parts हैं, Indian and Australia, but इसको मिला के एक बोलते हैं. Again, part continent, part ocean. ये ocean part blue है. This is the South American plate here. ये South American plate है like this. Part continent, part ocean. Okay. This is the Nazca plate, ये वाला. This is Nazca plate. This is Scotia plate. Your atlas will have all of this. You can open up any atlas of yours. There will be a page on the tectonic plates. Scotia plate. यहाँ पर Cocos plate है. यहाँ पर Caribbean plate है. We have the Arabian plate here. We have the Philippines plate here. This massive one. This is the Eurasian plate. और यहाँ पर छोटा सा होगा Burma plate. I'll expect you must draw this back in your room. Draw the world map, whatever way you can map. Okay? And have an idea about the boundaries. So all these diagrams I'll share with all of you as a part of your post-class notes. And see that. We'll give you a simpler one also. आपके notes में attach करने के लिए. Maybe this one will help a bit more. ठीक है? So this you can draw back in your room. So leave maybe half a page ताकि आप घर जाकर draw कर पाएं इसको. You have to draw the sketches. ठीक है? So these I'll share with you. You can always add up here. Yes, partly yes and partly no also. But for most considerations, we consider India and Australia to be together as a part of one plate. इसलिए हम उसको Indo-Austral plate लिखते हैं. There is no relative motion between them, but there is some boundary there. ठीक है? All done, all of you? Yes. अलग से प्लेट है ना, उसे पार्ट क्यों बोल रहे हो? अरेबियन प्लेट पूरा अलग प्लेट है, वो पार्ट ऑफ अफ्रीका नहीं. ठीक है? इंडिया एंड ऑस्ट्रेलिया दो अलग प्लेट है, बट ये जो बाउंड्री है ना, ये बाउंड्री एक्टिव नहीं है. दिस बाउंड्री इज नॉट एक्टिव, सो दे एक्ट एज वन प्लेट. इट्स लाइक आई हैव टेकन टू बॉडीज और मैंने इसको थोड़ा जोड़ दिया है. ओके, द फैक्ट इज ये दो अलग टॉपिक, अलग बॉडीज हैं, राइट? आई फ्यूज दिस हियर. Okay, so they act as one body, but they actually are not one body. So some write Indian plate and Australian plate separately, but this boundary is not active. So we can consider this as Indo-Austral plate also. Priyanka, all of that बाद में. Ur is part of Karnataka. In Karnataka, okay, जो plateau है उसके पास में एक छोटा सा प्लेट है जो फ्यूज हो गया है. इट्स कॉल्ड एज उर प्लेट. यस, स्कॉशिया ये साउथ में है, इसमें दिख नहीं रहा, यहां पर है, यहां पर है स्कॉशिया प्लेट. Anatolia plate, part of Turkey. You've heard about Turkish earthquakes, right? It's a plate called as Anatolia plate. ऐसे बहुत सारे हैं. You remember 4-5 of them. Don't kill yourself on the list of the plates. ये प्लेट्स किस बेसिस पे क्लासिफाइड है? इट्स ऑल सब्जेक्टिव. जो बड़ा दिख रहा है लार्ज है, तो छोटा है तो छोटा है. देयर इज नो डायमेंशन, इससे बड़ा है तो बड़ा है. I can move on now. Okay, so you don't need more than this. So what are the plates? Back to our discussions. Okay. So these are the plates you're supposed to know. Now give a subheading: a plate interactions and the associated features. Plate interactions and the associated features. Interactions and the associated features. Now, there are three possible interactions between two plates. You all notice one thing, no? I don't take too much of time to beautify the diagrams. We just want neat, clean diagrams. Okay. You should be able to show what you want to show. That's all. No scale. Don't use all the tools to draw. Rounder compass nahi chahiye hame. Freehand, okay, drawings. Freehand drawings to capture whatever you want to convey. So there are three types of interactions. One is the two plates can move away. They move away. We call this as divergent interaction. And this boundary is called as divergent boundary. The two plates can collide. We call this as collision interaction and collision boundaries. Or the plates can slip past. They don't collide. They don't move away. They slip past. They slip past. Something like they rub against each other. We call these boundaries as transform boundaries or transform interactions. There are three types of interactions. Divergent, when the plates move away from one another. When the plates collide against each other, or the plates can slip past or rub against each other. No collisions and no divergence. Yes, Abhirup, collision is also called as convergent. Okay? In some books they write convergent boundaries or convergence interactions. They move, okay, into one another. Okay, so it's like two plates, they collide, collision boundary. They move away, divergent boundary, or they can rub like this. Okay, this is neither moving away nor moving towards. This rubbing interaction is called as transform. So we have convergent boundaries, divergent boundaries, and transform boundaries. Okay, three types of interactions. I'll start with divergent boundaries. So give a heading, divergent interactions, or the features of divergent boundaries. Divergent interaction or divergent boundaries. Yes. No. A fault is not same as boundary. Okay. Fault is what? The crack. This is the lithosphere. Your friend is asking me, difference क्या है transform fault में और transform boundary में? This is a lithosphere. Okay. This is a crack. फट गया. But ये अलग नहीं हुआ. अगर ये टूट के अलग हो गया, then I'll call this as a boundary. So transform fault में the plate has not broken and moved apart. ये crack है. It's like, I have a fracture and I have a crack in my bone. दो अलग चीज है, right? The bone can break and they can separate completely. फिर वो दो अलग piece बन गया. This is just a crack. It's a rift valley here. So transform fault is not same as transform boundary. ये fault भी होता है because of this motion. Okay. और ये भी होता है because of this motion. हाँ, if the fault continues to get stressed और धीरे धीरे ये पूरा फट के अलग हो जाएगा, तब हम बोलेंगे boundary. So if this process goes on and after some time for some reasons ये पूरा टूट के अलग हो गया, ये पूरा separate हो गया, अब बोलेंगे इसको boundary. The boundaries में there are two different plates. Just in a fault, the same plate which has cracks. ठीक है all of you here? So in the more discussions, I said they are faults because वो अलग नहीं हुआ है. Remember how I had drawn it? This was the ocean floor. Ocean floor में this is the Moore system. Okay. And I said यहाँ पे ऐसे cracks हैं. ये cracks पूरा फैल के अलग नहीं हुआ है. ठीक है? There are some cracks here. But crack has not broken the block completely अलग नहीं किया है. These are transform faults different from transform boundaries. Is it okay? ठीक है. Let's move on now. Our discussion was divergent interactions and divergent boundary. Let's सुन लो for 2 minutes, then I'll give you the notes. So, say this is the plate. This is the lithosphere rather. Continent यहाँ पर है. ये ocean है. Another continent fought by another ocean here. Another ocean here. एक और continent होगा यहाँ पर. The convection cells can be anywhere. Convection cells, okay, can be anywhere. They can be rising here, sinking here. They can be rising here and they can be sinking here. Okay, the convection cells, okay, can have any dimensions. ये convection cell है. Imagine this is the ocean floor and the cell is here. Can you all imagine here? Okay. In a special case where the rising limb is under the ocean. ये rising limb है. ये ocean floor है. Here it will crack and this moves like this moves like this. This is what Harry Hess was talking about. So Harry Hess said, okay, the sea floor spreading जो process है, it's an example of a divergent boundary where the rising limb and the limb moving apart. This takes this plate on this side and this on this side. So यहां से यहां तक एक प्लेट है, ये अलग हो रहा है और ये अलग हो रहा है. The rising limb can also be under the continent, which Harry Hess did not talk about. Okay, Harry Hess is a special case of a divergent boundary. अगर यहां पर होगा, यहां पे वही होने वाला है. This pulling apart, the continent can break and I'll have a deep crack here. Okay, so write down 4 points here. देखो आप, write down. Divergent boundaries are associated with. The first point, divergent boundaries are associated with rising limbs of convection cells. They are associated with rising limbs of convection cells. Okay. As the rising limbs, diverge apart, as the rising limbs diverge apart, the plates, the lithospheric plate above, the lithospheric plates above will also be pulled apart. The lithospheric plates above will also be pulled apart. No problem here? Okay. So as a divergent boundary is a link to what? The link to ascending limbs. Remember convection cell का ये part है, एक rising limb होगा, divergence होगा, sinking होगा, and convergence. This is what is, okay, a convection current system. Remember, you always have a rising limb. These are two diverging limbs. These are the descending limbs, and these are the converging limbs. So when magma rises and moves apart, it will also pull the plate apart. So this plate starts moving apart. Number two, these rising limbs can be under the ocean lithosphere or under the continent lithosphere. These rising limbs can be under the ocean lithosphere or they can be under the continent lithosphere. Continue karo. These can break the oceans or the continents and pull them apart. They can be under the oceans, they can be under the continents. Okay, they can pull the oceans or the continents apart. Okay, they can break and they can pull the oceans or the continents apart. ठीक है, तो यहां पर this case A is rising limb under the oceans. Case B is rising limb under the continents. Put a star mark. The sea floor spreading process of Harry Hess, is a special case of a divergent boundary, under the oceans. Special case of divergent boundary under the oceans. ठीक है, so Harry Hess जब theory बता रहे थे, he had considered this alone. He did not consider this as a possibility. Okay. Okay. Third point. The divergent boundaries will be associated with an axial rift valley. Associated with an axial rift valley. ये दोनों में होगा, रिमेंबर. अगर ओशन पे है, you have a rift valley at the Moor. याद आ रहा है आपको? अगर कॉन्टिनेंट पे होगा, यहां पे रिफ्ट वैली होगा. Rift valley is in both cases. Okay. So rift valley essentially क्या है? It's actually location where the plate has broken. और वो अलग हो रहा है. So every divergent boundary is linked to a rift valley, the crack where the plates are getting pulled apart. Rift valley. Okay. And if active, there can be volcanic eruptions. If active, there can be volcanic eruptions. जब फट रहा है, फटेगा तो lava from the mantle will come out. Lava of the mantle will come out. It will crack here. Lava will come out. Lava will come out. Okay. Put a star mark and write down within bracket right now. Such volcanic eruptions are always basaltic eruptions. Such volcanic eruptions are always basaltic eruptions. They're always basaltic. Lava आ कहां से रहा है? What source of the mantle? So of the lava? Mantle. Mantle is made up of what type of rocks? याद आ रहा है? Ultramafic rocks. Rocks like peridotite बताया था मैंने. Rocks like dunite होगा. But when coming out, the rock converts. वो change हो जाता है. Okay. It does not remain as peridotite or dunite rocks. The hot conditions में some interactions happen. Okay. It's something like your distillation process. Okay. When you are having a mixture of liquids, okay, and you heat it, all the liquids will not evaporate one time. वो अलग-अलग evaporation होगा. So within bracket mention or mention here itself, the mantle itself is peridotite or dunite rocks. The mantle itself is a peridotite or dunite rocks that convert into basalt. That convert into basalt at divergent boundaries. They convert into basalt at divergent boundaries. Remember this, okay? This is a process called as partial melting. I'll explain again when I come to volcanism. It's called as partial melting process. इसमें ये rocks जो है ना, ये convert हो जाते हैं. There is some transformation happening and it changes into basalt. And did I mention basalt is hard or soft? Basalt is soft. Okay. Soft rocks will not erupt very powerfully. Soft rocks आराम से धीरे से निकल के बाहर आ जाएंगे. So wherever we have this type of eruptions, they are not violent eruptions. So maybe margins में your choice लिख लो. Basalt being softer igneous rocks. Basalt being softer igneous rocks. Igneous rocks. The eruptions will not be explosive. The eruptions will not be explosive. So more volcanoes are quiet volcanoes. Therefore, more volcanoes are quiet. volcanoes. याद रहा आपको all of you? So, what points? Number one I said was the divergent boundaries, they develop always at ascending limbs. Ascending limbs where the mantle convection cells are moving apart. And as they move apart, the lithospheric plate on top will break and will also get pulled apart. And this plate can be an ocean plate breaking or it can be a continent breaking. Okay? So, sea floor spreading is a specific example of a divergent boundary under the oceans, a special case. Then I said, whenever these eruptions happen, there will be a rift valley always. Crack hoga, definitely, from where lava comes out. And these type of cracks can be on the oceans, like we have at the Moor, or they can be also on the continents. And third thing I said, that if the process is active, in some process, it can stop also. Agar active process hai, I'll also have volcanic eruptions. The volcanic eruptions will always be basalt eruptions, remember this. And basalt by natures will not be explosive. Basalt eruptions are always quiet because basalt rocks are soft. Basalt lava is very fluid lava. Aram se beh jayega. It will not cause tsunamis, big earthquakes. They are very quiet, gentle earthquakes without much of tectonic damage. All fine, all of you? Okay. Next slide now. Next slide now. Okay. Divergent boundaries are locations of crust creation. The locations of crust creation. Remember, we have two types of crust. क्या बताओ? We can have continent crust and we can have ocean crust. Continents are made up of what type of rocks? Granite rocks, made up of diorite rocks, made up of andesite rocks. What type of rocks are oceans? Basalt rocks. So at spreading boundaries, what type of lava is coming out? Basalt is coming out. So at spreading boundaries or divergent boundaries, what type of crust is being created? Oceans are created. So all the locations of divergent boundaries have ocean floor creation. Remember this. Write down. उसी में add करो. The crust formed are always oceanic crust. The crust formed are always oceanic crust. क्या मतलब है इसका? Okay. तो अगर ocean floor है and lava is coming out, what type of crust we are creating? Basalt, no problem here. अगर continent है and it is breaking, तो continent will break, ये अलग हो जाएगा और बीच में क्या बन जाएगा? Ocean ही बनेगा. Okay, so continent will break apart like this. ये दूर दूर चला जाएगा ऐसे और बीच में this is the ocean floor which is being created. So when continents also break, they are replaced by ocean floor. You can all imagine here. Okay, so whether it is ocean floor that is moving apart, what's coming out is ocean basalt, or it is continents moving apart, what's again formed is an ocean. Which is thicker, continents or oceans? Which is thicker, continents or oceans? Which is thicker? Continents are thicker. Oceans are thinner. The ocean is formed whatever water we have around this will enter here. Below sea level always, no? Okay, so imagine, okay, this was a large continent, and for some reason, this continent broke up into South America and Africa, and they have moved apart. When they are moved apart, okay, South America has come here, Africa has come here. तो बीच में क्या रहा आपका? What is here? Oceans. ठीक है? So when a continent breaks and moves apart, like what happened for Gondwana land, बीच में क्या बन गया? This is Atlantic Ocean, right? Right? So when continents break, where is that? When continents break, बीच में क्या बनेगा? Ocean. This is South American continent. This is the African continent. So it's right. South America and Africa were once together. They broke apart और बीच में बन गया the Atlantic Ocean. Yes. I'll come to that next. Is समझ में आया all of you here? Okay. So I said spreading boundaries are always because of rising diverging limbs. The rising diverging limbs can be at the oceans or at the continents. Whenever we have rising diverging limbs, the lithosphere will break. There will be an axial rift valley. Oceans पे होगा या फिर continents पे होगा. Okay. When the rift valley is formed, you always will have volcanic eruptions. The basaltic eruptions होंगे. If the system is active, because basalt is being added means the oceans are being added. When I say ocean, I mean the ocean rocks are being added. So whether it is a divergent boundary at the oceans or divergent boundary at the continents, in both cases, the ocean crust is forming ultimately. That's why the divergent boundaries are locations of crustal formation. Okay, they are locations where the crust is forming. That's why we call divergent boundaries also as constructive boundaries. आप heading में लिख सकते हो. You can call them as divergent interactions, or you can also call these as constructive boundaries. Why constructive? Because ocean floor is created. That's why they are constructive. Because ocean floors are created. All done? Any questions in this? Any doubts in this? Underline the keywords. One is convection cell. Second is under oceans and continents. Third is an axial rift valley. The fourth is the basalt formation. ये 4 points हैं आपके. ये keywords याद रहेगा, your answer is on. Convection cells rising and diverging. They can be under the oceans, under the continents. There will be a rift valley and they're associated with basaltic eruptions and they are creations of the ocean floor. Okay, next write down sequence in the development of a divergent boundary. The divergent boundary जो बनता है ना, ये random नहीं बनेगा. There is a proper sequence, there is a proper event का flow, a sequence in the development of divergent boundaries. Divergent boundaries. इतना दूर नहीं जाएंगे अभी, यहीं धीरे धीरे. नर्मदा रिफ्ट वैली एक डाइवर्जेंट बाउंड्री नहीं बना, वो बस क्रैक है. बाउंड्री इज नॉट सेम एज क्रैक, रिमेंबर. Narmada Rift Valley, Mahanadi Rift Valley, or Godavari Rift Valley. They are rift valleys, that's all. They are not boundaries. Boundaries का मतलब है तो पीस पूरा अलग होके पूरा they will move apart. ऐसा नहीं हुआ. All done here? Okay. So what are the events? We say, write down, the sequence can be assumed to start from under, the sequence can be assumed to start from under the continents. Start from under the continents. देखो ये कहीं भी हो सकता है, okay? It's like, I'm drawing a circle. अब बनाने के लिए I must start somewhere, right? I can start from here और ये बन गया सर्कल, or I can start from here और ये बन गया सर्कल, or I can start from here, ये बन गया सर्कल. I must start somewhere, right? The process is a cyclic process. Okay, so we say, let's assume the process starts from the continents. हम आज शुरू करते हैं, but it can start from anywhere. Okay, so what we have now, watch this. There is a continent first, a large continent. For some reasons, I do not know. Okay, there can be a rising divergent limb, a very powerful convection system. What this can do is, because of this force here, this continent can get deformed. The continents, okay, जैसे हुआ था वो ऐसे फूल जाएगा. Can you all imagine here? Because of the push from below, okay, the continent has swelled out. If it keeps on pushing, next step क्या होगा? Okay, this bulge here can develop cracks. I hope you know this is the ocean floor. Okay, this is the ocean floor. I'm assuming the process starts under the continents. The ocean floor. Okay, a continent, because of strong convection cell, the continent is swelling out. Phul gaya. We continues a bit more. There can be cracks. This crack is a rift valley. This bulging out is called as domal upliftment. It's like an upraised plateau. The highlands ban gaya ye. Domal upliftment. Then we have a rift valley, a crack ho gaya. If the process goes on, okay, this rift valley will completely crack. ये पूरा टूट गया. ये ओशन है. Completely broken, cracked. And the continent is moving apart. Now it's the proper divergent boundary. And as it opens up, okay, I will have a small ocean formation here. Okay, this is the nascent ocean, young ocean. This young ocean will have basalt floor. And if this process continues, the two continents are now very far away with a proper more, very far away with a proper more, and the continents have now completely moved apart. Make sense, all of you? This is a proper ocean with a central more. So these are the sequence in the development of a divergent boundary. And see, the process starts, I'm assuming, from an undercontinent. The continent undergoes domal upliftment. The continent will get stretched, pulled, Rift Valley. The continent breaks, moves apart. A young ocean formed and a proper ocean floor like Atlantic Ocean is formed. Now, bana lo na, if you have understood this, you can make it now. Draw kar lo, I'll help you label the details. Yes, Preetha, in this example, I started with, let's assume starting from the continents. The ocean crust is formed, but the continents break apart and they have moved away. The continents are replaced by ocean floor. Draw the diagram first. I'll help you with the labeling. प्रियंका, ज्यादा सोच रहे हो. When the swelling happens, Priyanka is saying, sir, yahan se bhi phat sakta hai. Okay, when the bend happens, the crack starts from top. The upper part is stretched more than the lower part. Diagram ho gaya, all of you? So stage 2 is stage 1, the start of convection cell. Stage 2 is called as domal upliftment. The stage of dome as in swelling. Domal upliftment. This is an upraised plateau. An upraised plateau. This is the stage of continental stretching and rifting. Label it, please. The stage of continental stretching, खींच रहा है, and continental rifting. हो गया? Then we have the stage of continental crust split. Continental crust completely splits. पूरा अलग हो गया. Completely splits. This is the stage of nascent ocean, as in young ocean. The stage of nascent ocean. छोटा सा ocean floor है. And ocean का मतलब है, I'll have now basaltic floor. The nascent ocean with a basaltic floor. And the stage of proper ocean with central moor. The stage of proper ocean with central moor. ये example है. This example is the Atlantic Ocean. The Atlantic Ocean with South America and Africa now moved apart. The Atlantic Ocean with South Africa and South America and Africa now moved apart. ये सही आइडिया है. एक टाइम ऐसे था when South America and Africa they were together once, now broken and they have moved apart. ये जो एग्जाम्पल है, इसका एग्जाम्पल है रेड सी. रेड सी इज लाइक अ नेसेंट ओशन, नया बना है, लाइक एन नेसेंट ओशन. ठीक है. दिस स्टेज, ये जो स्ट्रेचिंग रिफ्टिंग स्टेज है, दिस इज द स्टेज ऑफ अफ्रीकन रिफ्ट वैली. In Africa, there is a north-south large rift valley. The stage of African rift valley. और ये जो स्टेज है, domal upliftment, we find this at Ethiopian highlands. Ethiopian highlands. Ethiopia country है, it's mountainous. I'll draw all of this for you, don't worry. Example of this is the Ethiopian highlands. For present day. Yeah. We see this in the present day continent. Yes. The Africa, we can see all of this happening. Krish, which one do you want to see? This part here? This part? No, Chetna. When the crust is forming, it's actually the lithosphere forming. We will never have only the ocean. We have the ocean with the upper part of upper mantle. So I'm using the word crust. I actually mean the ocean lithosphere forming, the continental lithosphere breaking. Okay, the stretching of the lithosphere, the breaking of lithosphere. The crust I've used only for convenience, that's all. But whenever I say crust, I actually mean the entire thickness up to the upper part of upper mantle for the first 100 kilometers of the thickness. Chaitanya. Well, Abhay, we'll see what that means. Drawing ho gaya aapka? Now write down a few lines, write down. The process of divergent boundary formation. The process of divergent boundary formation is not random. The process of divergent boundary formation is not random. It may be considered as the sequence starting from under the continents. It may be considered as the sequence starting from under the continents. Under the continents that forces the continents to stretch, rift and split apart. The continents to stretch, rift and split apart, allowing for oceans to form in between. Allowing for the oceans to form in between. Next slide down. Next slide down. This process can be seen in active in active operation in Africa. Process can be seen in active operation in Africa. Write down. The 1, 2, 3, 4. Number 1. The African Rift Valley. The African Rift Valley is in the stage of continental rifting. Rift Valley is in the stage of continental rifting. Number 2. The Ethiopian highlands are example of domal upliftment. The Ethiopian highlands are an example of domal upliftment. Number 3. The Red Sea is a nascent ocean. The Red Sea is the nascent ocean that marks the breaking away of Arabian plate, that marks the breaking away of the Arabian plate from the African plate. Arabian plate from the African plate. Now say, politically we say, Arabia is part of Asia and Africa is separate. But if you go by geology, Africa ka extension hai Arabia. The rocks of Saudi Arabia, the rocks of, parts of Yemen, they are similar to rocks of Africa. Let me show this diagram to all of you once. Sorry. Yeah. So, this is the Rift Valley. Rift Valley is like this. Okay. Something like this. It comes here. ये Rift Valley ऐसे. और ये Rift Valley ऊपर जाता है ऐसे. Goes along the River Jordan. River Jordan flows along the Rift Valley. And we have one arm here. This is the Rift Valley. So, this part of Africa टूट के अलग हो रहा है. And here we have lakes called as Tanganyika Lake, Lake Malawi Lake, Tanganyika Lake, lakes. A lot of small lakes here. And this is Ethiopian highlands. ये वाला part. This is Ethiopian highlands. Okay. And Africa, okay, this part of Africa is breaking away from Saudi Arabia. वैसे, this is called as Somali plate. ये भी ऐसे अलग हो रहा है. They'll separate out maybe in couple of million years. The Africa has this massive rift valley. Okay. So, if I draw this diagram, it's like this. Equator. This is Lake Victoria, Sinai Peninsula, and this is Arabia. The Rift Valley है, वो कुछ ऐसे है. Rift like this. यहाँ से खुल गया ऐसे. It goes along this. It goes along this. ये ऐसे जाता है इधर. And on this side, it's like this. And here we have lakes, Lake Malawi, Lake Tanganyika, small lakes are here. Okay. And this part here, this is the Ethiopian highland here. This is your African Rift Valley. Okay. Lake Malawi, Lake Tanganyika. यहां पर कुछ लेक्स हैं called as Lake Turkana. We have Lake Albert. This is Ethiopian Islands. This is the Red Sea. And yahan par this is the Jordan, a river, and the Dead Sea. Yeah, draw this please. Nothing on the board is for entertainment. अगर हो रहा अच्छी बात है, वो एक्स्ट्रा आपका बेनिफिट है. आप बनाओगे सारा. हाँ. तंगानाइका और लेक तंजानिया. Lake Tanganyika. Lake Malawi, also called as Lake Nyasa. The old name of Malawi was Nyasa, Lake Nyasa. Yes. ऑफ करना है. आप सबको ठंड लग रही है. Yeah. All done? Write down. In the future, the eastern part of Africa, as a part of Somali plate, the eastern part of Africa as a part of Somali plate can break from rest of Africa. As a part of Somali plate can break from rest of Africa. If this goes on, okay, Africa probably will become something like this. And this part of Africa would have broken away. इधर चला जाएगा. And this part would have gone further away. That is how Madagascar must have separated out. That is how Gondwana must have broken. Okay. There are two lines here. Write down. Write down. The divergent boundary is the mechanism how continents break and move apart. Divergent boundary is the mechanism how continents break and move apart. This is what must have happened for Pangaea and the Gondwana land. Must have happened for Pangaea and the Gondwana land. Now we said no, that Wegener's idea galat thodi hai. The continents were once together, they broke away, sahi hai baat. But the mechanism is the divergent boundary mechanism, not like what he said, the sun and moon pulling and breaking the continents. No, all of them are normal faults, not transverse faults. ये खींच रहा है ना? When they're pulling and breaking, okay, they are not transverse faults. All fine, all of you done? This is the development of divergent boundary. Now, I want to add one point here. Okay. सुन लो पहले या फिर लिख लो, write down. Add here. Any divergent boundary starts with a triple junction that grows and develops into a proper boundary. Any divergent boundary starts with a triple junction that grows and develops into a proper boundary. That grows and develops into a proper boundary. Okay? So, what I'm saying is, अगर ये कॉन्टिनेंट है, मैसिव कॉन्टिनेंट से, when the breaking happens, it's not a continuous crack forming suddenly. It always starts with a crack which has three arms like this. A crack which has three arms like this. A crack with these are called as triple junctions. And these triple junctions will expand, they'll fuse, expand, they'll fuse. When the expansion happens, always two arms remain active, one will die. Two will remain active, one will die. Two remain active, one will die. Which one will die, you can't guess. Okay. Ultimately, कैसे ऐसे फैल जाएगा? Okay. And this part will now separate out. Okay. जब टूटेगा, there are three junctions, and ultimately you can imagine here. So this used to be your triple junction here. This was this triple junction here. And this was the triple junction here. Now the two pieces अलग हो गया. अरे this. The two pieces are not separate. So this crack is called, yeah. No, it has three arms meeting at one point. इसको बोलते हैं ट्रिपल जंक्शन. Yes, it's always three. Why ये physics का part है? We skip that part. Even I can't explain. Whenever cracking happens, it always happens with three arms. ठीक है? और उसमें फिर दो ग्रो करेगा, एक will die off. इसको बोलते हैं failed arm बोलते हैं. Add one sentence here down. Huh? Continents, yes. Write down. Give a subheading, triple junctions. Give a subheading, triple junctions. I just want you to add one sentence, that's all, nothing more here. Write down. It's actual phenomenon. Yes, we also have locations also. Write down. Continental rifting at divergent boundaries. Continental rifting at divergent boundaries always start with triple junctions. They always start with triple junctions, which have three arms of rifting. Which have three arms of rifting. As the divergent boundary develops, two arms remain active. Two arms remain active. And a third arm will become the failed arm. The third arm will become the failed arm. Within bracket down, which can activate later. Which can activate later. But of the other two, one must again become a failed arm. But of the other two, one must again become the failed arm. What I'm saying is, when you have a triple junction like this, okay, all the three will not be active at the same time. Say today, maybe this and this active or ye dead hai. In the future, it's possible this can again activate, then one of this will become failed arm again. At any given time, two will be active. Okay? So, in a triple junction, one is a failed arm. In the future, this can activate, but of the other two, one must convert into again a failed arm. The failed arm hai, it's also called as allocogen. The failed arm is also called as allocogens. A-U-L-O-C-O-G-E-N. It's also called as allocogens. Okay. Now, in case of Africa, okay, there is a triple junction यहाँ पर. ये एक triple junction है. Imagine, okay, this as one arm, this as a third arm, this as a second arm. This is a country called Djibouti. Djibouti. In Djibouti, there is a location called as Afar. Afar Junction बोलते हैं. Afar Junction is a triple junction. Okay, so add कर लो. An example of a triple junction is An example of a triple junction is Afar junction, AFAR. Afar junction in Djibouti, DJIBOUTI. Afar junction in Djibouti. And as of now, of these three arms, the failed arm right now is ये अफ्रीका वाला, ये failed arm है, ये अभी active नहीं है. Okay, right now this and this are active. In the future, we are anticipating that this will die and this again will become active. That's how Africa will again break. How they anticipate this, I can't explain that. But as of now, this is how it operates. It's cracking. That area is showing movements. The area will have earthquakes. As of now, this African part is the quiet part. This and these are active ones. Take all of you. Doesn't happen. That's it. Accept it. That's all. Yeah, leave it there. That's where your geography ends, physics starts. Leave it. The best example of triple junction is if you have seen baking of cakes. When the cake ferments and it bulges out, there will be a crack on the top. If you have taken a fruit plum cake, dekho, the top will have a crack. And always a three-arm crack. You put icing and you cover that up. Okay? Okay. Next point. Give a subheading, mantle plumes and convection cells. Mantle plumes and convection cells. Now, dekho. Convection cell is what? It's a massive system. If I draw a two-dimensional one, can you imagine this here? Convection cell. So, all of you here? This is a convection cell. Where everywhere, magma is rising, magma moving apart. Magma rising, magma moving apart. Magma rising, magma moving apart. हर जगह हो रहा है. Magma moving apart. Magma moving apart. Magma moving apart. And above this, lithospheric separating out. A convection cell does not develop immediately. What happens is, before the convection cell develops, there are localized eruptions like this. There are localized eruptions here. Think of one thing. Think of above this roof, there is a massive water tank. And the roof is not strong. How will the roof break? Okay. First what will happen is the roof will have a slight bulge like this. It will sag down like this. Then you can see roof will develop some small cracks. Then at some point water dripping starts. The water dripping localized hai na? Slowly, gradually. The crack will open up more. The water comes down like a sheet now. And ultimately the whole roof breaks. So before the whole roof breaks, can you imagine there are dripping waters? So वैसे ही. This is a localized dripping water. Localized dripping water. Thousands and thousands of such rising will create one convection cell. And this rising magma is the mantle plume. The mantle plume is the beginning of a convection cell. When a convection cell develops, the whole crust breaks and moves apart. But जहां पर mantle plume होगा वो क्या होगा? एक localized volcano होगा, एक localized crack बनेगा, right? That is your triple junction. It's like, you know, I am trying to tear a paper. मुझे paper फाड़ना है. I take a paper and I puncture one hole here. I puncture one hole here. I puncture thousands of holes here. Then the whole thing now becomes a crack. A paper फट जाएगा पूरा. So each puncture is like a mantle plume. Okay. So one mantle plume here, crack. One mantle plume here, crack. One more mantle plume here, again a crack. Thousands of mantle plumes together. When they all combine and mature, now the whole paper will come apart. So the triple junctions are actually the mantle plumes to start with. So one mantle plume rising up here, some crack here. It may or may not have volcanism. One mantle plume here, okay, a crack here, may or may not have volcanism. So mantle plumes are the initiation of the convection cells. But not all mantle plume ultimately become convection cells. Some of them can stop in between. Is it okay all of you here? The two lines right down. Mantle plumes and localized volcanic eruptions. Mantle plumes and localized volcanic eruptions are the initiation of ascending limbs of convection cells. They are the initiation of the ascending limbs of convection cells. The triple junctions are associated with such mantle plumes, which eventually become divergent boundaries. Okay? So this one, okay, there must be a mantle plume here. There must be one mantle plume under this. There's a mantle plume under this. धीरे धीरे ये और intensify होके the whole thing now becomes a crack. It's okay all of you here? Okay. So that's for today. We continue tomorrow. Tomorrow I'll try finishing off the convergent boundaries, but revise this and come. No, for this right now, no readings. I'll let you know when to read from the books. Okay? Okay then. Bye-bye all of you. Tomorrow same time. Bye. Revise and come please.